Hey there. So as you can see, our today's topic is gravitations, and this video is from chapter 3 unit E from ICSE class 9 syllabus. Okay, so now first of all we have to know what is gravitation. So before telling that, I must tell you that who discovered the laws of gravitation. Of course you know Newton's discovered the laws of gravitations. So first of all, let us know what is this law of gravitation. Okay, let's say this is a mass of value m1, and another mass is here, let's say of value m2, another mass of value m2. Okay, and let's say they are separated by a small distance or any distance r. Now according to the Newton's law of gravitation, we know that the force acting between these two masses, is F, that is proportional to the product of these two masses and inversely proportional to the square of the distance between them. What I am saying? So the force of attraction, basically of course force of attraction, is proportional to the product of these two masses and inversely proportional to the square of the distance between them. Now if you combine these two, what you will get? F equal to a constant g into m1 m2 by r square. So this g is known as the universal gravitational constant or the gravitational constant. Okay, so whatever, this is laws of gravitation and this law is discovered by Sir Isaac Newton. Okay, now one thing I tell you, suppose this is object 1 and this is object 2. So this F force is basically the force given by object 1 on object 2, and oppositely we can say this F force is also equal to the force given by object 2 on object 1. Actually both are same. From Newton's third law, action and reaction both are same actually. Okay, now let's talk about this G. What is the unit of G? If we talk about SI unit, so before that let's find what is this G equal to. So we got the equation F equal to G into m1 m2 by r square. So directly we can write G equal to F into r square by m1 into m2. Okay, now it is our aim to find the unit of G. Now let's find the SI unit. Okay, so unit of G, that is equal to unit of force, that is Newton, unit of distance squared, so that is meter square, divided by mass into mass, that's mean kg into kg, so kg square. So what is the unit of G? As we can see from here, Newton meter square kg to the power minus 2. This is the unit of G. Okay, if we want to find the CGS unit, then what will be the unit? Unit of force, that is dyne in CGS, unit of distance, that is centimeter square, and unit of mass, that is gram square. So the unit will be dyne centimeter square gram to the power minus 2. So this is the CGS unit. Now what is the value of G? You must have to keep in mind what is the value of G. In CGS, value of G is 6.67 into 10 to the power minus 11 SI unit. So what is this unit? This unit is Newton meter square kg to the power minus 2. So the value is 6.67 into 10 to the power minus 11 Newton meter square kg to the power minus 2. You need to remember this. Is it okay? Now how to define this G? How we will define this universal constant, that's mean gravitational constant G? So basically I am telling you how to define. We have this formula F G equal to F into R square M1 M2. So just do one thing. I am rewriting the formula here. So G equal to this formula, F R square G equal to F R square M1 into M2 M1 into M2. Now do one thing. Let's say M1 equal to 1. I'm taking M1 equal to 1. Also M2 equal to 1. And the distance between them are equal to 1. So what is basically here? I am taking two unit mass separated by a unit distance. Okay, so if we consider the CGS SI unit, so kg and this will be meter. So if two 1 kg masses are separated by distance 1 meter, then how this formula changing? G equal to F into 1 square by 1 square, that's mean G equal to F. So how we are defining? If two masses of 1 kg are separated by a distance 1 meter, then the force acting between these two masses is known as the gravitational constant G. Is it okay? And the definition is given in your book as gravitational constant G is numerically equal to the magnitude of force of attraction between two masses each of 1 kg placed at a separation 1 meter. Okay, this is from your book and this is given. Okay, so just this is the overview of the formula, Newton's law of gravitation. Now let us know about the characteristics of the force. Okay, that's mean what is the character of this gravitational force. So first of all, I must tell you number 1 point, that this force is always attractive. That's mean two objects always attracts each other, there is no repulsion. Okay, so two objects always attracts each other. So point number 1 is the force is always attractive. Number 2 is directly proportional to the product of the masses. Okay, is directly proportional to the product of the masses. Number 3, inversely proportional to the square of the distance between them. Okay, basically just look at one thing. What is the value of G? That is 6.67 into 10 to the power minus 11. Little bit small, na? Actually this is very small, 6.67 into 10 to the power minus 11. So 1 by 1 followed by 11 0. So can you imagine? Now just look at this formula. Suppose M has some specific value, this M also have some specific value, and this R also have some specific value. So basically this quantity can be little bit bigger, but as the value of G is very small, so the force become very small. That is why the force become very small. Okay, and for that, gravitational interaction is the weakest interaction in our universe. What I am saying, gravitational interaction or gravitational force is the weakest force in our universe. Is it okay? So gravitational force is the weakest force. You must have to know this. Next, force due to gravity. Okay, force due to gravity. So let's talk about this. Let's say this is our earth. Okay, what is the radius of the earth? We are taking radius of the earth as capital R. Capital R is the radius of the earth and capital M is the mass of the earth. Let's say an object of mass small m is situating on the surface of the earth. Okay, now what is the force of attraction between the mass m and the earth of mass capital M? So from Newton's law we can say that F equal to G into capital M small m by R square. capital M small m by r square. Basically, this is the force by which Earth is pulling this object. So this is the force by which Earth is pulling this object, and this force is known as the force due to gravity. Is it okay? Now let's find the acceleration due to gravity. From the previous lesson, what we have learned? So from previous lesson, we know that according to Newton's second law, F equal to ma. F equal to ma, that is force equal to mass into acceleration. Okay, force equal to mass into acceleration. Now if you consider this object, the force on this object, if F, that is equal to its mass into its acceleration. Now as here the force is gravity, so instead of acceleration, this acceleration, we shall take this one, m into g, because we know the force by which Earth is pulling this object, that is its weight, m into g, and that weight is equal to this force, right? Because this is also the force by which Earth is pulling this object, but we know this is the force, so instead of this F we can use mg. So I am writing mg, that is equal to g into capital M small m by r square. So we can cancel out this m and this m. So what we are getting, g equal to gm by r square. G equal to gm by r square. This g is known as the acceleration due to gravity. You already know this g equal to acceleration due to gravity. Acceleration due to gravity, and you must have to remember this formula. In previous classes you have already used this value. Its CGS SI value is 9.8 meter per second square, and its SI value is 980 or sometimes 981 centimeter per second square. So it is its value. Is it okay? So you must have to remember this formula, and this is also known as the relation between small g and capital G. This is already given in your book. Okay, now how to define this acceleration due to gravity? This is very easy. The rate at which the velocity of free falling body increases. So let's say this is an object coming towards Earth. That's mean it's free falling. So how we are defining this g? The rate at which the velocity of a free falling body increases is called the acceleration due to gravity, because we know acceleration is known as the rate of increase of velocity, but in this case the object is falling towards the center of the Earth, basically towards the center of the Earth, but it may stop here on the surface of the Earth, but its speed is increasing due to the force by which Earth is pulling this object. Okay, so the rate of increase of speed of a free falling body is known as the acceleration due to gravity. Is it okay? And it's equal to g equal to gm by r square, and its value is 9.8 meter per second square. Of course, one question came into your mind, sir, can I write 10 meter per second square? And I must tell you, no, you will not write. You are now in class 9. So you have to write 9.8 meter per second square. Sometimes for the simplicity of numerical problems, you can write 10 meter per second square, but its original value is 9.81, but I am considering it's 9.8 meter per second square. Is it okay? Now I am giving you an example. What is the value of g on Earth? That is 9.8 per meter square. Now what is the value of g on Moon? What is the value of g on Moon? Okay, basically the value of g on Moon we can calculate very easily. So g Moon, that is equal to g into mass of Moon by radius of Moon, and its square, mass of Moon by radius of Moon and its square. So if we just put all the values, and that is already done in your book, I am not going to do this. If you put all these value, you will find that acceleration due to gravity on Moon, that is equal to 1/6 of acceleration due to gravity on Earth. Okay, this proof is not important for exam, but you have to know this for the short questions. Okay, so acceleration due to gravity on moon is 1/6 of acceleration due to gravity on earth. Okay, now in case of free fall, okay, we shall find the form of one dimension equation of one dimensional motion in case of gravity. Okay, when we are write this equation, when we write this equation, v equal to u plus at, that's mean our object is going through a path, whose initial velocity is u, final velocity is v, going with an acceleration a, and t is the time. Okay, but in case of a free falling body, we shall write this type of equation, v equal to u plus gt. So a body is free falling, that's when it is falling like this, that's when a body is falling like this. So that's mean it is falling with an acceleration g, acceleration due to gravity. So instead of g a I shall write g. When it is coming downward, its velocity will increase. But when I throw it, what will happen? Throw it upside, what will happen? When I throw it upward, what happen? Instead of acceleration, retardation works. Because when you throw an object upward, its velocity decreases. That's mean that retardation. Okay, that's mean this equation is for downward motion, and when I write v equal to u minus gt, that is upward motion. That's mean retardation is g. Similarly, the equation v square equal to u square plus 2as, this equation will be turned into v square equal to u square plus 2gh, where s is the displacement along a straight line path, but here h is the height. So when it is falling from a certain height or coming upward on a certain height, then it will be v square equal to u square minus 2gh. So just one thing keep in mind, when upward, then retardation, and when downward, then acceleration. Because when it is coming downward, earth is pulling it, and when it is going upward, then also earth is pulling it, and that is why it is a slow down motion. That's mean retardation is working there. Okay, we have another equation, s equal to ut plus half at square, and this equation will turn into h equal to ut plus half gt square, or sometimes h equal to ut minus half gt square. I'm telling you one thing. Suppose you are just releasing an object from upper side. You're just releasing an object. That's when its initial velocity is 0. That's when all the u will be 0. Suppose you are throwing an object upwards, then its final velocity means all the v will be 0. Is it okay? So when you are releasing from a certain height, then initial velocity u equal to 0, because initially it is at rest. And when you are throwing an object upward, then what is happening? Coming at certain distance, it is stopping for a moment. Coming at certain height, it is stopping for a moment, and then it is again falling down. So the final velocity will be 0 here. Is it okay? Now, according to your book, what is the next concept? The next concept is about mass. So what is mass? Basically, mass is the amount of or the quantity of matter in an object. So mass of a body is the quantity of matter it contains. This is the mass. But what is weight? What is weight? The weight is the force by which earth is pulling an object towards its center. What is weight? Weight of a body is the force with which the earth attracts it. In other words, weight of a body is the force of gravity on it. So weight of the body is the force by which earth is pulling this object. Okay, so let's say this is the earth and this is pulling the object small m towards its center. So what is the force of attraction? F equal to g into m by r square. We are saying that this F is actually the weight W. Is it okay? So this F equal to W, and we know W equal to, so what we are getting? W equal to we are getting g into m by r square. But initially we have taken this is equal to small g. this thing equal to small g. So W equal to, we can write m into g, and this is well known to us that mass of an weight of an object, that is W equal to m into g, and the value of g is 9.8. Is it okay? So one thing you have to read. Oh, another thing, what is the unit of force? We know the unit of force is Newton, but what is the gravitational unit of force? The gravitational unit of force is kgf, or gram force, gf, kgf or gf. So the force on a 1 kg object is 1 kgf, the force on a 2 kg object is 2 kgf. To convert in Newton, you have to multiply it with 9.8 or 980 according to the unit system you are following. So next thing you have to read, that is the difference between mass and weight. So difference between mass and weight, that is very much important. So mass is the object contained in a body, weight is the amount of force by which earth is attracting you. Mass is a scalar quantity, weight is a vector quantity, as it is a force. Its unit is kg, its unit is Newton. Okay, so this type of points are here already in your book. Okay, and the next topic in your book, that is gravitational unit, already I have told you. Okay, so this is the overview of gravitation according to the syllabus of ICSE board. Whatever, if you find any problem, you can tell me in WhatsApp group or in the comment section of this video. By the way, subscribe my channel. Thank you.